Hello everyone, welcome to our session today. We will continue our discussions on the solvable groups of trigonometric integrals. As we had discussed last time, we talked about group number one, integrals of the form like this. So these are the forms where m and or n are positive integers. Then we solve one example, and there are three cases for this group one. So case one. So these are the rules. These are the things that we need to follow when we dealt with case one. So case one example. So we have this example and we have solved this problem already. And we also have solved example for case two. And these are uh, the procedure that we're going to follow when we solve problems belongs to this case two. M n is odd factor. So this is the rule that we're going to follow. And Uh, today we are going to deal with case 3 when m and n are even. Okay, so these are the following identities that we will use when dealing with this case 3. Now, for example, if you're given something like this, and if you can remember in our previous discussion, I discussed about the reduction formula for integration. So that formula is very useful when we dealt with case number 3. Okay, so I will give you the solution for this problem quickly, and then in the next video I will give you the details of how the answer was derived. All right, okay, so we are given this integral of sine to the fourth x times cosine squared x dx. All right, so in our discussion about the formula of or the reduction formula of or for integration, so we know how to solve this, right? We know how to solve this, and in this one we transform this into something that contains sine. We use the trigonometric identities so that everything will be in terms of a sine, no, sine x dx. All right, so we have here the initial step. So we have to use the okay, so this is by the way, this is the answer, no? So I will uh, give you the details of how this answer was derived. So these are the steps. So first we need to rewrite this given using the trigonometric identities. We have to transform this into its equivalent expression, which is equal to 1 minus sine squared x dx from the trigonometric identities. Okay, and then when we expand, so when we expand this, so the result will become sine, where we're dealing with the integrand. We have, when you distribute this and multiply, so we have sine to the fourth x minus sine to the sixth x, or we have now the result equivalent expression of this is simply the integral of sine to the fourth x minus sine to the sixth x dx. Then using the reduction formula for integration, of course we have to apply this rule. Now, when you have this expression, you just sum up or subtract the given uh, integrals. Then using the reduction formula for integration, so we obtain this the equivalent, no, the integral equivalent of this. I mean the result of integrating sine to the fourth x dx is equal to this one. You may see the details of how this result was derived by watching the separate video about the reduction formula for integration. And then we have, no, same for the second term. We also use the reduction formula for integration to get this result. All right, so after getting this result, then we have to substitute it here. Okay, so after substituting, we get this. Okay, so this part, so this is the one that is for the first term. Okay, and then minus, so the result for this, the result of the second term, which is equal to this one, then substitute it here. So we have this, then simplify. So when you simplify this one, we obtain this result. Okay, then actually this line class is just the same with this one. Then adding the constant of uh, integration, so we get this answer. Okay, so p over 8x minus 1 over 24 sine cube x cosine x minus 3 over 16 sine 2x plus 1 over 6 sine to the fifth x cosine x minus 5 divided by 32 times the quantity 2x minus sine 2x plus c. Okay, so this is the result of this integral of sine to the fourth x cosine squared x dx. So this is the case 3, no? Case 3, where m and n are both even. And these are the these are the datas of the solution for this problem. Okay, so you might wonder why you get this result. Then in the next video, I will give you the datas of how this result was derived. Okay, so that's all for now, and see you again in our next video. Bye.